Hey guys, clap your hands. We are finding the inverse of a function. Okay, it's very exciting stuff happening. All right, you will notice this one says find the inverse given the restrictions. These are my restrictions, so what is up with that, right? Okay, what we always need to remember when we are finding the inverse of a function is in order for a function to have an inverse, it needs to be what we call one-to-one, okay? What does that mean? Well, let's hurry and graph what this guy is going to look like, okay? Pretend these aren't here for just a second. So if I were to graph this, I know it's a parabola, right? If you need a refresher on how to graph a parabola, I'll link a video in the corner. But to graph this, I'm going to shift to the left 3 and up 1, right? So my graph, again, this won't be perfect, but I know a parabola looks a little something like this, right? Okay, beautiful, okay? All right, in order for a function to be one-to-one, it needs to pass the vertical line test, right, to be a function. And then it also needs to pass the horizontal line test, okay? If you're like, what on earth is that? Again, I'll link a video in the corner, okay? All right, vertical line test, you're probably used to. It passes it, awesome. It doesn't cross 2 points at once, so we're good. It's a function. Now, the horizontal line test is the same thing, but you probably guessed it, with a horizontal pencil or whatever, okay? So I notice right here, right, with my horizontal line, I cross 2 points, right? So this means it is not a one-to-one function, okay? So if this weren't here and my teacher asks me to find the inverse, I could say, this one doesn't have an inverse, okay? But we have these restrictions. So let's see what happens when we apply the restrictions, okay? The restrictions are x is greater than or equal to -3, okay? So here's my -3 on my x-axis. So we only want the ones greater than or equal to -3, meaning this guy's gone. This half is totally gone, okay, because of these restrictions. So if that's gone, watch what happens for my horizontal line test. We're good, it passes, right? So that is why the restrictions are so important. If these weren't here, this would not have an inverse. This by itself doesn't have an inverse, but when we apply that, it does, okay? So let's go ahead and make this more official with some marker, okay? So this is going to look like this. Now this isn't gonna be perfect. I'm not finding every point on here, right? But it's gonna look something like that, right? Okay. Now we are going to find the inverse of this, okay? The first step when I do this is I'm first going to change my f of x to a y. Just makes my math easier, okay? So I'm going to have y equals x plus 3 squared plus 1, okay? All right, the next thing I'm going to do, it's about to get crazy, all right? I'm going to switch my x and y variables, okay? Swap them. So I'm going to have x equals y plus 3 squared plus 1, okay? If you're like, why is this a thing? This doesn't seem legit, okay? Let me show you why it's legit, okay? So on this graph, I have the point -3, 1, right? That is a point on my graph. So that means the inverse of this graph has the point 1, -3, okay? Do you see how the x and y are swapped, okay? So we could literally find every point on this graph or a bunch of them and I tried to say swap and switch at the same time. Switch the x and y. But a much quicker way to do that is to just take our equation and swap the x and y, and then we're gonna solve for y, okay? So to solve for y, first I'm going to subtract 1 from both sides, okay? So I have x minus 1 equals y plus 3 squared, okay? Now how do I get rid of that squared? The opposite of squaring is taking the square root, right? So I'm going to take the square root of both sides. That cancels these guys out, okay? And then we must remember that whenever we introduce a square root into a problem, what do we need? We need our plus or minus, okay? Why? Because the square root is asking me what number multiplied by itself gives me whatever number's under here, right? So imagine there was a 9 under there. The square root of 9 is 3, right? But the square root of 9 can also be -3, right? Because -3 times -3 is also 9. So that's why we add that plus or minus there to account for both of those answers, okay? Now I'm going to have plus or minus the square root of x minus 1 equals y plus 3, okay? Now I can subtract that 3 from both sides. And I end up with plus or minus the square root of x minus 1 minus 3. You could have written that 3 out front too, just kind of preference, is equal to y. Okay, I switched which side the y was on just because that's how I'm more used to seeing it, right? Okay, so this is what I believe my inverse is, but let's go ahead and graph it and see what we're looking at, okay? So for two functions to be inverses of each other, they are reflected across the y equals x line, which is just what cuts my graph diagonally in half, right? That's the y equals x line. Okay, so pretend that's a mirror, right? So this graph should be reflected on the other side. Another way I like to think of it is pretend this is like wet paint, right? The green, and I fold it over and like stamp it. And what would it look like on the other side, right? If I fold it along that line. That's what this graph should look like, okay? So let's go ahead and do it in pencil first. We're going to be graphing this square root, okay? Also, make sure you stick around for the end because we're not going to leave that as a y as well, okay? So if I were to graph this, did I already say this? I'll link a video in the corner if you forgot how to graph these. But I'm first going to do the positive, okay? So that would mean I go to the right one and down 3. Oh, look, there's that one -3 point we were talking about. And then it would look something like this, right? And then the negative side would be at that same point and go down, right? Something like that, like a sideways parabola, right? But guess what? When I do this, that doesn't pass the vertical line test. It's not a function, okay? But that can be pretty easily remedied, right? So I only need one of the halves, right? So which half is a reflection of this guy? Well, it's the top one, right? It's the positive one. So basically what I'm going to do is I don't need this negative, right? That is not part of my inverse. So I'm going to have y equals, I could write positive, but we don't usually write it, right? Just the square root of x minus 1 minus 3, okay? That is my inverse. Well, almost. I got to change this in just a second. So let's, again, make this guy more official. So I'm at the point 1, -3, and I'm just doing the positive side, so it's going to look something like that, right? Now pretend my graphing is perfect, right? But can you see how it's reflected over that y equals x line, okay? All right, the last thing I need to do, and make sure you do this because you could potentially get docked points if you don't do this, is we change our y to f inverse of x equals that square root of x minus 1 minus 3. And that, my friends, is my inverse, okay? All right, I hope this made sense. If you need some more inverse videos, I will link a playlist for you. Thanks.